In this video, we're gonna continue about curve sketching. In example 4, we have fx equal to 2x squared over x squared minus 1, and we're gonna gathering information in order to graph the curve. So you have fx equal to 2x squared over x squared minus 1. The first thing that you notice will be you see x squared minus 1, and the domain turned out to be the bottom guy, not equal to 0. So you have x squared minus 1 not equal to 0. So in this case, you would get x not equal to plus or minus 1. Okay, so this is what you have for the domain. So you have everything except 1 and negative 1. The x-intercept, okay, so the x-intercept, so you have 2x squared over x squared minus 1 equal to 0. So you would get 2x squared equal to 0, and you will get x equal to 0. So you have x equal to 0 to be your x-intercept. And y-intercept is f0, so it's going to be 0. Okay? And you're going to have horizontal asymptote. For horizontal asymptote, it will be just limit x go to infinity of 2x squared over x squared minus 1. For this one, you just have 2x squared over, you have x squared, 1 minus 1 over x squared, and you see that you have 2 over 1 equal to 2. And in a similar manner, you can have x go to negative infinity, and it's going to give you equal to 2 as well. Okay, so you set up in the same way. So for the conclusion, you're going to have y equal to 2 to be your horizontal asymptote. Okay, so this guy, it's going to be horizontal asymptote. Okay, so in this case, this guy will be your horizontal asymptote. And for vertical asymptote, it's going to be the bottom equal to 0. So you have x squared minus 1 equal to 0. And in this case, you will get x equal to 1 and x equal to negative 1 are vertical asymptote. Okay, so this is what we learned before for horizontal and for vertical asymptote. Okay, the next one, you're gonna differentiate. So for f prime x, so you're gonna differentiate the first, the bottom derivative of the top minus the top derivative of the bottom. So that's gonna take kind of long, so I differentiate it for you. So you get 4x over x squared minus 1 square. Okay, and for f double prime, this guy would be 12x squared plus 4 over x squared minus 1 to the third. Okay, so for both of this one, you have equal to 0, you have equal to 0. So you will solve for the endpoint in this case. So in this case, you're gonna get 4x equal to 0. So you get x equal to 0. And here you get 12x squared plus 4 equal to 0. Okay, so you would get no solution. Okay, however, don't forget that you're gonna see that you have this guy, and this guy will be the one that you see that it's gonna be the derivative does not exist. It does not exist because you not be able to compute f at 1 and f at negative 1. So this one will not be the inflection point and will not be the local maximum. However, you must include these two guys in order to check the sign. Okay, so in this case, this one will give you the boundary. So x equal to 1, negative 1. And here you have x equal to 1, negative 1. We have to include these 2 points on the bar, on the side changing, because this one is in the expression in the f prime and in the f double prime. So let me draw a real number line. So you see that the thing that I'm gonna put in the real number line turned out to be negative 1, 0, and 1. And we're gonna check for the sign of f prime. For the sign of f prime, you're gonna pick one number in this interval, one number in this interval, and one number in this interval. And you're gonna see that this one, when you have x equal to 2, you get negative. So you're gonna get negative sign in this interval. And for x between 0 and 1, like x equal to 1/2, you also get negative sign. Okay, and you have positive for this one when x equal to negative 1/2, and when x equal to negative 2, you also get positive sign. Okay, so in this case, you're gonna see that you're gonna have increasing, increasing, decreasing, and decreasing. So you're gonna get maximum at 0. Okay, so you have maximum at 0. So let's conclude everything. So you have the critical number is going to turn out to be just x equal to 0. Okay, so you have x equal to 0 to be your critical number. Okay, and let me emphasize this one, that x equal to 1, x equal to negative 1 are not in the domain. So we not be able to include them in the critical numbers. Okay, so they are not in the domain. And you have f is increasing, so you see that it's going to be the interval that you have positive sign. So it's going to be negative infinity up to negative 1, and you have negative 1 up to 0. And f is decreasing on 0 to 1 and 1 to infinity. Okay, the next one will be local maximum. It's going to be 0 f0, so it's going to be 0 0, and you have no local minimum, so you just say none in this case. And you're gonna have to check about the concavity. So you're gonna have this real number line again, and you're gonna plug in the point negative 1 and 1. Okay, and you're gonna have psi of f double prime. So you are checking the psi of f double prime. So it's gonna be, you're gonna plug in one number. Okay, so you're gonna plug in 2 into this guy, So you see that you have 2 and you have 2. So you to the third, so you're gonna get positive sign. And when you plug in x equal to 0, you get negative sign. Okay, so you plug in x equal to 0, 0 here, you're gonna see that you're gonna get negative sign. And for the next one, you plug in negative 2 again, you would get positive sign. So you're gonna conclude that this one will be up, down, and up. Okay, so it's gonna be up, down, and up. So the concave up will be negative infinity to negative 1 and 1 to infinity. And for concave down, it's going to be negative 1 to 1. And the inflection point will be the point that the concavity change from up to down and down to up. However, you may think that this guy and this guy will be your inflection point. However, it's going to turn out to be not in our domain. So in this case, I'm going to say none. Okay, negative 1, 1 are not in our domain. Okay, so that's the reason. So you're gonna, we're gonna sketch the graph. So in this graph, you're gonna need like something kind of or quadrant 1, 2, 3, 4. So you're gonna have this one and this one, and this guy will be y and x. Okay, and you have to draw first the horizontal asymptote. So you have horizontal asymptote, which is y equal to 2. So you draw y equal to 2 as your horizontal asymptote. Okay, so you have 2 here, and you're gonna have x equal to 1 and x equal to negative 1 vertical asymptote. So this one will be negative 1 and 1 for vertical asymptote. Okay, and then what? And then you're gonna gather the sign. Okay, so let me write down the sign of f prime. And you're gonna have the sign of f double prime. For the sign of f prime, it's gonna be negative when you have x more than 0, and it's gonna be positive when you have x less than 0. And for the sign of f double prime, it's gonna be positive when you have x more than 1, and negative when x between 0 and 1, and you have positive. Okay, so in this graph, you see that it's going to be 4 cases. It's going to be this interval. Okay, so it's going to be this interval, this interval, this interval, and this interval. So it's going to be 4 interval that you have. And you're going to write down the shape. So you're going to have the shape of the graph in each interval corresponding to the sign of f prime and f double prime accordingly. So you're going to have positive, positive. So the shape would be like this, and positive, negative in this interval. Negative, negative is going to be decreasing and concave down, and you have negative, positive. So it's going to be decreasing and concave up. Okay, so this is how we have the shape of the graph. Okay, let me draw this one a little bit lower because I will need this space. Okay, so it's gonna be here, it's gonna be here, and it's gonna be like this. So you have the limit x go to infinity equal to 2 on both sides. Okay, so you have this one, and I know that it's gonna be above this line because when you plug in, so when you plug in x in this interval, so you see that, how would I know that it's gonna be something above this line or below this line? I just try to plug in like some number in this interval. For example, I'm gonna plug in x equal to 2 to see where my graph will be. So when x equal to 2, you see that it's gonna be negative 2 square over 3. So you see that it's gonna be about 8 over 3. 8 over 3 is gonna be above y equal to 2. And you know that when you have x go to negative infinity is gonna tend to 2. You may ask me, why don't you have something like this? Can we have something like this? We cannot, because what? Because if you have something like this, you see that this guy will be giving you the local minimum. Okay, so this guy will give you the local minimum, and we know that we don't have any local minimum at all. So it's not be able to be like something like this that is going to be zigzag or anything. So it's going to be a nice smooth curve. So for this one, you gonna just have the graph in the way that it's gonna be horizontal tangent line at y equal to 2 and vertical tangent line at x equal to negative 1. And the shape of the graph turned out to be increasing and concave up. So you're gonna graph this guy as follow. So it's gonna be like this. Okay, so this is the one that we have. Sorry. Okay, you may need this guy a little bit higher. Okay, so this one is going to be the first interval. For the second interval, you know that you have the graph passing 0, 0, and this guy will be local minimum. Okay, so your graph will be having horizontal tangent line like this. Sorry, it's vertical tangent line. And you see also that it's gonna become like this on this interval. Okay, and you have on the other side turned out to be this shape. Okay. So for this example, you may plot some point in order to give you some guideline. For example, you may plot when x equal to 3, okay, just plot. When x equal to 3, you may plot this one is going to give you 18 over 8. Okay, so when you have x equal to 3, so you get 18 over 8. And this will be the point that above the line y equal to 2, and that gonna give you a guideline in order to know that it's gonna be above this line. Okay, and this is the whole graph that we have. Okay, so it's gonna be psi of f prime, psi of f double prime. So this is the whole picture of this one. The next one, okay, again, you have the function given by something, okay, in this case, gonna be log of 4 minus x squared, and we're gonna find the domain of the function. For the domain of this function, if you recall the domain of the log function, the domain of the log function is the thing that sits behind the log must be positive. So you're gonna have 2 minus x, 2 plus x, positive, okay? And you draw or you do the sign test. So it's gonna be x equal to negative 2 and x equal to 2. And you're gonna see that it's gonna be negative, positive, and negative. So you're gonna have the solution lies between negative 2 and 2. Okay, so in this case, the domain will be negative 2 and 2. So you have very, very small domain in this case. Okay, and for x-intercept, you're going to have the fx equal to 0. So it's going to be log of, let me show it here. So it's going to be log 4 minus x squared equal to 0. So you get 4 minus x squared equal to e to the 0. Okay, so you get x squared equal to 3 because e to the 0 equal to 1. So you would get x equal to root 3 and minus root 3. Okay, so this will be your x-intercept. So it's gonna intercept the x-axis at root 3 and negative root 3. And y-intercept will be f at 0. F at 0 will be log 4. Okay, so you have f at 0 equal to log 4. And you have horizontal tangent line. This one will be none. Okay, because the domain, like I told you before, the domain is very small, so it's going to be just negative 2 to 2. So you not be able to go to infinity or go to negative infinity. It's not going to make sense. And for the vertical asymptote, okay, for the vertical asymptote, you know that log 0 equal to negative infinity. So you're going to look for x such that it's going to give you log 0. So you have 4 minus x squared must be 0, and you have x equal to 2 and negative 2. Okay, so this one will give you the vertical asymptote. And for the first derivative and second derivative, this one is easy. So you dip log, it's going to be negative 2x over 4 minus x squared. Okay, so that's going to be just derivative of the thing that sit behind the log. Okay, so this one is u, right? So this one is u. So derivative of u is going to be negative 2x, and it's going to be over u. And for the next one, it will be using the quotient rule. So it's going to be the bottom derivative of the top something. Okay, let me differentiate this one. So it's going to be the bottom derivative of the top minus the top derivative of the bottom. So it's going to be minus 2x, right? So it's going to be minus 2x over the bottom square. And so you will get negative 8. Okay, so you would get negative 8, and you get what? Negative 2, right? So it's going to be negative 2 plus negative 2x squared. So you have this guy, and it's going to be 4 minus x squared squared. Okay, so you're gonna see that this one will be no solution. So if you have this guy equal to 0, it's gonna turn out to be no solution. However, if you have f prime equal to 0, you would get x equal to 0. So this one will give you a solution. And you see that you're not gonna go outside negative 2 and 2. So when you draw the real number line, as we have done before, so you're gonna draw this guy. So this guy will be like this. And you draw this one, you see that you're gonna have minus 2 and 2. Okay. And you see that you're gonna find the sine of f prime. Okay, so you see that you're not gonna have anything outside, so it's gonna be this one will be inside this interval. It's gonna be open interval, and you're gonna have your 0 in the middle, and you're gonna plug in the side. Okay, so it's gonna be, you're gonna plug in x equal to 1 here. It's gonna be what? It's gonna be 1. It's gonna be negative on top, positive on the bottom. So it's gonna become negative. Okay, and you have when x equal to negative 1, it would become positive. Okay, so this one will be the psi for f prime. The next one will be the psi for f double prime. So you have -2 and 2, okay? And you have no solution. So you have no infraction point around here. So you're gonna just plug in for psi of f double prime. Okay, so it's gonna turn out to be, so you plug in what? You plug in x equal to 0 into the equation, so you get negative. So this one means that your graph always concave down in this case. And you're gonna also conclude from the side of the first derivative that this one, the critical number is gonna be x equal to 0, and increasing will be -2 to 0, and decreasing will be 0 to 2. Okay, so this one can be easily conclude. However, do we have maximum? So we do actually. So you see that it's going to be increasing to decreasing. So this guy will be maximum at 0 log 4. Okay, so it's going to be the point that we already have. And local minimum turned out to be none in this case. And concave up turned out to be none. And you have concave down. So this one will be concave down all the time. And this guy turned out to be -2 and to 2. Okay, and you have no infraction point. So this will be all information that we gather. So we're gonna graph the function. So for the graph of the function, so for this one, you're gonna see that this one will be your y and your x. Okay, so this one will be your y and your x. And you're gonna have the domain, which is just -2 and 2. So you're gonna, okay, I'm gonna make this one a little bit larger. Okay, so this one is -2 and 2. Okay, and you see that you have x-intercept at √3 and -√3 about 1.7. Okay, so this one is √3 and -√3. And you have log 4. Okay, log 4 is about 1 point something. So let me have my log 4 here. Log 4 is about 1 something. So in this case, you know that your graph is going to be increasing in this interval. It's going to be increasing and decreasing after 0. Okay. And for concavity, it's always concave down. Okay. So you're going to have the shape. So the shape of the graph will be increasing concave down and decreasing concave down. So it's going to be just kind of parabola. However, it's not parabola because we have vertical asymptote. So we have our vertical asymptote. So this one will be your vertical asymptote. So in this one, you would draw this graph. Okay, so you have to aim for passing. You have to aim for passing -√3. Okay, so it's look like this. And you're gonna draw the graph, okay, in another direction that gonna pass +√3, and it's gonna tend to this vertical asymptote. Okay, so it's gonna be symmetric actually. So this one and this one will be symmetric, and you have this one. And you know this guy is symmetric because log 4 minus negative x squared will turn out to be equal to log 4 minus x squared, and that's the reason why when you have negative side and positive side, they give you the same value. So it's going to be symmetric graph. Okay, let me draw this one in a symmetric way a little bit. I would suggest erasing. So for this one, come down. Okay, so it's gonna come down like this, and that's gonna be my graph. And you see that it's gonna passes through this point, and this point. That is gonna be our x-intercept and y-intercept respectively. Okay, let me. I would want, if I were you, I'm gonna fix this one a little bit. Okay. Wish me luck in this case. Okay, not quite good. I may have to. Okay, I think we have the one that I'm looking for. Yeah. Okay, so this one will be symmetry with respect to the y-axis. Okay, let's do the last one. For the last one, you have fx equal to x squared over root x plus 3. The domain will be just, you have the inside square root here is positive. So you have x plus 3 positive. So you get x is more than negative 3. Okay. And you have x-intercept. X-intercept, you're gonna see that you have x squared square root x plus 3 equal to 0. So you have x equal to 0. And y-intercept will be f0 equal to 0. Okay. And you have no horizontal tangent line because you have limit x go to infinity of x squared over square root x plus 3. Actually, this guy turned out to be positive infinity. Okay, so this guy turned out to be none. And do we have the vertical asymptote? For vertical asymptote, you have the bottom guy equal to 0. So you get x equal to negative 3. Okay, so that will be your vertical asymptote. For a prime, okay, so let me differentiate this one for you. So that kind of huge derivative. So it's going to be 3/2 x squared plus 4x, okay, and you have x plus 3 to the 3/2, okay. So by using the quotient rule and this one equal to 0, you would get x plus 4 equal to 0. So you get x equal to 0 and negative 4. However, negative 4 is outside the domain. Okay, so it's outside our domain. So we not include x equal to negative 4. Okay, so we're gonna just answer critical number. So turn out to be just x equal to 0. For the next one, it's going to be for f double prime. So you get 3/4, okay? And you have x squared plus 8x plus 24 over x plus 3 to the 5 over 2. Okay. And you see that you kind of like to solve for this guy equal to 0 in order to obtain the candidate for the interaction point. So you would get x squared plus 8x plus 24 equal to 0. And you may just use quadratic formula. So you have negative 8 plus minus square root b square minus 4ac over 2a. So it's going to be 2. And you see that the thing that sits inside the square root turned out to be negative. Okay, so in this case, no solution. So we have kind of no infraction point. Okay, and you see that this guy turned out to be always positive. Okay, so the pink guy here is always positive. How would I know that it's always positive? It's always positive because when I plug in x equal to 0, you get 24 and positive. And you see that we have no solution. So it's not going to become lower than 0. So in this case, it's never negative. If you have positive and negative, they must be 0. Okay, so there must be 0. So this one is always positive. And so you're gonna draw and you're gonna check for the sign for me. So here I gonna have this one, and you have the domain is -3, so it's -3 first. Okay, and you have the sign of f double prime. Let me move this one up a little bit. Okay, shoot. So this guy will be -3, okay? And you have f double prime, so you get negative, okay? And you have one critical number, which is x equal to 0. Let's put 0 somewhere. You have 0. And let's check the sign for f prime. You have f prime. You see that when you use number in this interval, you're gonna pick x equal to 1. So you put x equal to 1 and 1 here, so it's become positive. And when you pick one number less than 0, it's gonna give you negative. Okay, so it's gonna be positive, negative. Hey, when you have positive, negative, you're gonna have decreasing, increasing. So this guy will be minimum. Okay, so this guy will be minimum. So it's going to be increasing on -3 to 0, decreasing on 0 to infinity. Okay, and you have local maximum x equal to 0, and you have local minimum, it's going to be none. Okay, so it's x equal to 0, you need the point, so 0, f0. What is f0? F0, we have 0, right? So it's going to be just 0, 0. And we have, sorry, I switched this one, right? So this one will be local minimum instead. Okay, and for local maximum will be none. Okay. And for concave up, concave down, you see that it's always concave down. So it's going to be -3 to infinity. And it's never concave up. Okay. So it's going to be that number. Oh, I put this wrong side. Sorry. It's going to be positive. I just realized that I make mistake on the side, so it's gonna be -3 to infinity, and it's turned out to be none. Okay, and you have no inflection point for sure. So this is what you have, and then we're gonna use the above guideline to graph. So for this one, you're gonna have the x-axis and y-axis. Okay, so you have x and y. Okay, so you have the domain. You're gonna begin at -3. So you're gonna begin at -3. Okay, and you have the important point, which is 0. Okay, and you're gonna put the sign. So you have negative, positive for f prime, and you have positive all the time for f double prime. Okay, and you see that you have vertical asymptote. Okay, so you have vertical asymptote, which is this line, and you have the shape of the graph. Let me have the shape. So the shape of your graph turned out to be negative, positive. So it's going to be decreasing, concave up. Picture look like this. And this one is positive, positive. So increasing, concave up. Okay, so this is the one. And you gonna plot the point that you know. So you know it's gonna be 0, 0 for sure. And you know that this guy will be going to this way, and you know that the limit x go to infinity, you get infinity. So you're gonna go in this direction. Okay, so it's gonna become, let's try this way. Okay, it's not good. Okay, so this one is on this side, and for the other side, you're gonna have x equal to 0 is the local minimum, and you're gonna go up. Okay, to positive infinity. So this one is going to be positive infinity, and this one is gonna go to this vertical asymptote. Okay, so this one is the graph. And you may ask me, hey, how would you know that it's not going to be below the x-axis at all? Just see your function. Your function always positive, as you can see. Okay, so you see positive over positive, so it's always positive. So you not have the chance that you're gonna get negative. So you're not gonna get in quadrant 3 and quadrant 4 at all. Okay, so that's why I know. Okay, so that's all for the application of differentiation, and we gonna stop derivative of the function and application. Okay, in the next, what should I say? In the next topics that we're gonna study, it's gonna be new topic. It's gonna be about integration instead. It's gonna be like a opposite direction for differentiation. We're gonna recover the function that has derivative equal to the given one. So that is gonna be new topic. Okay, and that is going to be more fun than this guy. However, that will be more difficult, and it's going to involving many algebra. Okay, so I think I gonna stop here, and we gonna go to the new topic in the next lecture.